Okay guys, in this video, we will discuss what is series and parallel inductors. In the later videos, last videos rather, that we have discussed what is series and what is parallel inductors. But this time around, what is inductor naman yung pag-uusapan natin. Now, as you can see in this figure, this is this circuitry. We have a certain circuitry having a series of inductors. We have L1 until Ln. So, alam natin that in a series, the summation of their voltages is equal to the source of voltage, as you can see in this equation. Now, we know that the formula for the voltage of an inductor is equal to V is equal to L di over dt. While for the iba yung sa current, which is say dV over dt. So now let's focus on this equation. So ngayon, ang V1 natin dito, V1, V2, V3 until Vn natin is pinalitan natin ng equation ng L di over dt. We have the L1 di dt, L2 di dt, L3 di dt, and until yung Ln di dt natin. Now, di ba, if this is series, meaning yung current na nag-flow dito is iisa lang. Now, itong current na ito, at saka ito, at saka ito, at saka ito are iisa lang sila. So, we factor out that. So, ito yung nangyari dyan. So, now we just have add them. We add yung L1 until Ln. Now, we have the summation of Lk, where k is equal to 1 and also n is number of yung inductor natin. Ngayon, therefore, ang L equivalent natin is simply we have L1 plus L2 plus L3 and so on. Ito yung pagkuha natin ng L equivalent sa series natin. And ito yung kalalabasan nito kung ito i-add natin lahat ng mga inductor natin. So we have this one V L equivalent. At kung mapapansin nyo, parehas din sila sa R equivalent ng series resistor. I-add mo lang sila. So, yan. Now, we have there, unlike doon sa series natin na we have the series na capacitor natin is we have ganito. We have C1 plus 1 over C2 over C3 and that plus 1 over Cn. Ito yung pagkuha ng equivalent natin doon sa series na capacitor. But then, ito yung pagkuha natin sa L equivalent natin doon sa series na inductor. So, we will then discuss what is parallel inductor. Okay, so now let's discuss what is parallel inductor. So, as you can see in this circuitry naman, it is obviously parallel inductors. Why? We have this one, and that one. So, we have the voltage here and we have the current here. Unlike doon sa current natin, sa series natin na connection is that yung common sa kanila or common sa mga inductors are same current. But then, dito naman is iba yung current na nag-flow dyan. But then, yun nga, parallel. Meaning, ang voltage nila is isa lang. We have the voltage if ever we have the source. So, therefore, we have a certain equation that this one, dito natin kukunin. Paano na-derive yung formula natin doon sa parallel inductors. Paano natin kunin yung L equivalent niya. If this is yung relationship na ito na meron doon sa parallel circuit natin, alam din natin na we have same voltages in all branches. And also, we have this relationship between the current and yung voltage natin. Ito ay kinuha galing sa, we have V is equal to L di over dt. So, we do the little separable yun nga, which is na-derive naman. So, now we have this series of equation. Ang ginawa natin is, ang equation na ito is pinalitan ng ito is pinalitan ng ganito, and same goes the others. Now, as you can see, since ang voltage naman is parehas sa kanila, so then again, di-crop out natin sila or di-factor out natin. And also, di ba, this one is yung initial natin na currents. But, alam natin, if we sum this one, pwede natin sabihin na yan yung initial natin, total initial current natin. Now, so, by doing that, we have this one. Na-factor out na yung voltage mo. And then, yun na. Ito yung i-add mo lahat ng inverse of the inductor. So, ngayon, nangyari dyan is ito na yung L equivalent ng inductor natin. And again, kung mapapansin nyo, pareha sila nung sa series ay parallel resistor. Try to check. And also, yung Rn. So, ganun siya. So, we have that one. Ganito lang yung pagkuha natin ng L equivalent ng certain na parallel inductor. Kung makikita nyo is yan. We have tried to add that. Kung ma-add mo ito lahat, at gustong makuha yung L equivalent mo is i-inverse mo lang to. We have this. Pwede natin sabihin na L equivalent is equal to inverse of 1 over L1 plus 1 over L2 plus 1 over L3 plus 1 over 1 over Ln. So, nakuha mo na yung L equivalent mo. And now, let's summarize or let's let's compare series resistor, series current inductor, tsaka series capacitor, and so on and so forth. So, we have this one. So, we have for resistor, ang series nila, we have, wait lang, we have this one. So, for series, we have series natin, series. We have ang R equivalent natin is simply equal to R1 plus R2 plus R3 plus that plus Rn. For L equivalent or inductor natin, we have L1 plus L2 plus L3 plus that plus Ln. And for the inductor natin, is simply equal to the inverse of 1 over C1 plus 1 over C2 plus 1 over C3 plus that plus 1 over Cn. Inverse. Ito is galing yan yung yun nga. In-inverse mo yung 1 over C equivalent mo. While for parallel, we have R equivalent natin is simply the inverse of 1 over R1 plus 1 over R2 plus 1 over R3 plus that plus 1 over Rn. Inverse yan. We have yan. We have that inverse. Ngayon, for L equivalent naman is ganun din. We have quantity 1 over L1 plus 1 over L2 plus 1 over L3 plus that plus 1 over L, and we have inverse. And for the capacitor, simply C1 plus C2 plus C3 plus Cn. And that's all. Ganun lang yan yung pagkuha natin ng respective nila na equivalent for series and parallel. So, as a summary, another additional information about resistor and capacitor up to inductor, we have this one. For relation for voltage and current, we have Ohm's law, we have V is equal to IR. And also for capacitor, simply we have V is equal to 1 over C integrals of I dt from t initial to t plus dot, which is galing dito na formula, which is nagseparable ka lang dyan. And also for voltage natin, which is LDI over dt. And for IV, we have I is equal to V over R. And also this one, and also ito is nag-integrate ka. And for power, we have P is equal to I squared R, and so on and so forth. And for energy, we have 1 half CV squared, and also we have 1 half Li squared. And for the series, we have this one, and also for parallel, and here. So for DC supply, we have same lang siya, as is lang siya. But for capacitor, nag-open circuit siya, while for open circuit siya for capacitor and also for inductor, we have short circuit. So let's try to have an example for parallel and series inductor. So we have this example. Let's try solving this example. We have finding the L equivalent in this terminal. As you can see, we have 20 Henry, 12 Henry, 10 Henry, and so on and so forth. So for this branch, we have 20 until 10 at saka 12. They are series. So let's consider that L1. We have 20 plus 12 plus 10 Henry. We have simply we have what's this? We have 10, 22, 20 plus 20. We have 42 Henry. Now we have 42 Henry, right? We have 7, 4, at saka 8. So now if we do, since we have 7 Henry and 42 Henry, they are series, let's consider that 2. We have inverse of 1 over 7 plus 1 over 42. So to, to calculate that one, we have 7 inverse plus 42 inverse and inverse. So we simply have 6 Henry. Now we have this one. Ay, wait, that's for resistor. Curly yung inductor natin. We have that one, and that one. Have 4, 8, and 6. So simply series lang sila. So ang L equivalent natin is simply 4 plus 6 plus 8. We have 18 Henry. So, gano'n lang siya kasimple. So, gano'n lang siya. And that ends our discussion on the inductor. And we will be moving on doon naman sa last part ng ating discussion, which is yung first order.